Good afternoon, Algebra 2. Just using Pokemon Go here today to help me tell a little bit of story about piecewise functions. So piecewise functions, okay? We've spoken about them a little bit already this year, but not formally. So piecewise functions are basically functions that come in different pieces. So let's say that over the summer, Mr. Theinert started playing Pokemon Go with Drew and Will Garrison, okay? Well, if I was playing Pokemon Go with Drew and Will over the summer, then at Salt, maybe we were catching, let's say we were catching 25 Pokemon a day for the first 7 days. Okay? And we'll make a little graph that goes along with this. So we've got day 1, we've got day 2, 3, 4. I don't like my graph, I'm going to erase it. Alright, so now that I've got that axis set up, let's graph it. So on day 1 I've got 25 Pokemon, on day 2 I've got 50, on day 3 I've got 75, on day 4 I've got 100, and it keeps going up like this until we get to day 7. Okay? Now on day 7 I get bored, so I stop. Me, Will, Drew, we're not playing anymore. We stop playing. Alright, but I still have the app on my phone, so if I stop playing, I still have whatever Pokemon, 25 times 7, let's see, 25 times 7 would be 175. I have 175 Pokemon in my deck, all right? And I stop for 2 days. So that's the 8th day and the 9th day, and that looks right about right, okay? And then what happens on the 3rd day, or the 10th day, is really bad. Logan hacks my phone, and he steals all my Pokemon. Well, when Logan steals my Pokemon, okay, I go right from where I was at 175, I skyrocket down in that one day down to 0 Pokemon. All right, and that's a piecewise function. We can see that I was increasing at first, okay, these are going up, all right, this is staying consistent, nothing is happening, and then all of a sudden dropping down. That's a piecewise function, a function that behaves differently in different places. So informally, how that looks, it looks like this. In your notes, you have f of x equaling x minus 3 from negative 3 to 0, that's the important part, and then 1/2 x plus 4 from 0 out to 4. So let's use our table here, and let's get a couple values. So a few values. If I want to plug in negative 3, I got to look over here. Where does negative 3 fall? I'm going to use the top piece. And negative 3 minus 3 is going to be negative 6. All right. Let's erase those marks so I can play the game again. If I look at negative 2, where does negative 2 fall out of those two? Negative 2 is in between negative 3 and 0, so I plug it into here. Negative 2 minus 3 is negative 5. All right. Erase. Start over again. Looking at negative 1, it still falls in there. I'll go to the top, and I'll go negative 1 minus 3, which is negative 4. And keep going with this idea. 0, now it starts to get a little bit tough. Where do I plug in 0? Where do I plug in 0? I kind of see 0 in both places, but you can just check, plug the 0 in for x, and ask yourself, in the top here, is 0 less than 0? No. All right. But in the bottom, it would say, is 0 less than or equal to 0? Yes. So I'm going to use the bottom function here. Half of 0 is 0 plus 4 is 4. And anything past 0, all three of these, 4 I should say, 1, 2, 3, 4, are all going to get plugged in to that bottom piece of our function. Right there. So half of 1 is half, plus 4 is 4.5. Half of 2 is 1, plus 4 is 5. Half of 3 is 1.5, plus 4 is 5.5. And half of 4 is 2, plus 4 is 6. Okay? And you can see your function behaving differently at different places. So what I'm going to do is I'm going to go ahead and pause the video and plot those points. Okay, so here is our points plotted, and I can draw the yellow line connecting those yellow dots right there. And if I draw the green line connecting those green dots right there, I have the two pieces of my function. Now, it's got to be very careful with piecewise functions, because if you look, if I were to test if it's a function, Whoop, not quite. It hit there, and it hit there. So that's no good. We got to figure out something to do. And it's kind of simple. What we do here is we look for the signs back up here. It's less than 0, so less than 0 means we use an open circle down here. That's an open circle. And for greater than or equal to 0, I use a circle and I fill it in. Alright, so this is just me filling in that circle. Okay? And now as I draw that vertical line, it hits the top, but it does not hit an open circle in the bottom. So that's going to be really important as we look at piecewise functions. And it's okay for there to be a jump. It's okay for all of that stuff. So anyway, that's a little intro to piecewise functions. I thank you all for watching, and I will see you tomorrow in class.